Good morning, children. Today we are going to discuss about ionic equilibrium. Okay, so this topic is present in 12th standard chemistry, unit 8, ionic equilibrium. Okay, what is the title? Ionic equilibrium. So in this ionic equilibrium is represented as the reversible reaction. So what is the general reaction of reversible reaction? So the general reaction is A plus B and W is C plus D. So in this simple is called the reversible reaction. So A plus B is a product and C plus D is A plus B is reactant and C plus D is product. So A plus B to give C plus D is a forward reaction and C plus D to give A plus B is a backward reaction or reverse reaction. Okay. So in this reaction, the reactant and product is concentration is equal. Okay, so concentration is equal. So in the ionic equilibrium, so ions how to present in the ion reaction equilibrium. So in the ionic equilibrium is specifically acid and base equilibrium. Okay, so in the ionic equilibrium is specifically acid and base equilibrium. Okay, ionic is acid and base equilibrium. So in the example, in our human body, so in the hydronium ion is react with the bicarbonate buffer solution is to form a formation of carbonic acid. Okay, so in the reaction hydronium ion. So in the hydronium ion formula H3O plus. Okay, hydronium ion. So in this hydronium ion is react with bicarbonate. Bicarbonate formula HCO3 minus, it is the aqueous medium and aqueous medium, and then the formation of carbonic acid H2CO3 aqueous medium plus water. Okay, so in this example reaction, carbonic acid to bicarbonate buffer in the blood. So in the H3O plus is hydronium ion is react with the bicarbonate to form of carbonic acid. Okay. So in the food items, present in the acid, the name is milk. So in the milk contain lactic acid. So in the milk present in lactic acid and vinegar present in acetic acid, and lemon and orange is present in citric acid, and tea is tonic acid and antacid tablet. So in the presence of aluminium hydroxide and magnesium hydroxide. So in this acid and base have many important industrial application. So the first one is the sulfuric acid. So what is the sulfuric acid formula? H2SO4, sulfuric acid. So in the sulfuric acid is used in fertilizer industry and sodium hydroxide in soap industry. Okay. So this is our introduction part. Then next go to the topic, the ionic equilibrium. So in the topic is acid and base. Okay, acid and base. So if you take your book page number 2 and take your note, you write the classwork topics. Okay. So in the first topic is acid. So acid, already see the acid names: lactic acid, vinegar acid, citric acid and acetic acid and tonic acid. Many acids is there. Yes. So in the acid, it is derived from the Latin word is acetus. Okay, the acid, it is derived from the Latin word is acetus. Is acetus. Okay. So in the acetus is the meaning is sour. Meaning is sour. So in the sour means புளிப்பு. Okay. So in the Latin word is acetus. Acetus meaning is sour. Then The tans it is tans blue litmus to red litmus paper. So it is tan blue litmus to red. Okay. Then the third point, acid is react with metal. Okay. Acid is react with metal zinc to produce H2 gas. Okay. Acid is react with metal. The metal example zinc to produce H2 gas. Okay, so this is the acid definition. So what is the acid definition? Acid, it is derived from Latin word. So the Latin word is acidus and the meaning is sour. Then it is turns blue litmus to red litmus. Then acid is react with metal. The metal name is zinc to produce H2 gas. Then the next topic is base. So base is the taste is bitter taste. Okay, base. So in the base it is bitter taste. Okay, so it is bitter. So bitter taste. So in the bitter taste means kasappu. Okay, so base it is bitter taste. So it is stands in the opposite. So as it is stands blue litmus to red. The base is red litmus to blue. Okay, so it is tan blue the red litmus to blue. Okay, so this is the base definition. The next topic, the concept of acid and base theory. The concept of acid and base theory. So there are three concepts. One is Arrhenius concept and Lowry-Bronstein constant and Lewis constant. So I'll have you write the topic. The concept of acid and base theory. Okay, children. So first topic is Arrhenius theory. Arrhenius theory or Arrhenius concept. Okay, so what is the first topic? Arrhenius theory. So in this Arrhenius concept, the acid and base is defined in aqueous medium. Okay, acid and base is defined in aqueous medium. Aqueous medium, the symbol is AQ in water medium. Okay, so in the acid and base acid and base is defined in aqueous medium. Aqueous medium. So next the acid. So acid and base. So in the acid is a substance that dissociates to give hydrogen ion in water. Okay, so in the acid is a substance. Okay, acid is a substance that dissociates to give hydrogen ion in water. Okay, hydrogen ion in water. For example, the HCl, hydrochloric acid to give in the presence of aqueous medium water, the H plus Cl minus. Okay, H plus Cl minus to form. So in the acid and base is defined in the aqueous medium. So in the hydrochloric acid, to formation of H plus ion. So in the hydrogen ion in aqueous medium water, then the chlorine aqueous medium. Okay, so in the H plus ion is react with water. Okay, H plus ion is react with water to form hydronium ion. So hydronium ion formula H3O plus. Okay. So H3O plus or H2O plus. Okay, this is hydronium ion is formed. Okay, so what is the acid? Acid is a substance that dissociates to give hydrogen ion in water. Okay, so the reaction hydrochloric acid to form H plus and Cl minus. So in the H plus is further react with water to form hydronium ion. So in the H plus ion in aqueous solution is highly hydrated. Okay, children. So in the H plus ion, okay. So in the H plus ion, the H plus ion in aqueous medium, aqueous medium solution is highly hydrated. Okay. So in the H plus ion in aqueous medium solution is highly hydrated. Then the next one, base. So base is a substance that is dissociated to give hydroxyl ion. Okay. So in the H plus ion is the acid, OH minus ion is base. So in the OH minus ion, so in the base is a substance that dissociates to give hydroxyl ion in water. So in the hydroxyl ion symbol OH minus. So for example, sodium hydroxide. So what is the sodium hydroxide formula? NaOH, sodium hydroxide. So sodium hydroxide to form Na plus metal and OH minus hydroxyl group. So in this hydroxyl group in presence in aqueous medium. Okay, aqueous medium. Then the next example, potassium hydroxide. So what is the potassium hydroxide formula? KOH is potassium hydroxide. So in this potassium hydroxide is decomposed to potassium plus OH minus is aqueous medium. Then the next topic, next example is calcium hydroxide. So calcium hydroxide formula CaOH2, calcium hydroxide. It is decomposed to calcium 2 plus 2OH minus aqueous medium. Okay, this is the example of base. So sodium hydroxide, potassium hydroxide and calcium hydroxide to the dissociation to give hydroxyl group. Okay, dissociators to give hydroxyl ion is OH ion in water, aqueous medium. Okay, children. Then next, limitation. So in this limitation, aluminium chloride. So what is the aluminium chloride formula? AlCl3. So aluminium chloride is a acid. Okay, aluminium chloride is a acid, but does not contain the hydrogen ion. Only aluminium simple Al, chlorine simple Cl. Okay. So aluminium chloride is a acid but does not contain hydrogen ion. So some substance present in acid medium by no hydrogen atom. Okay, no hydrogen atom. So no hydrogen ions was present in the substance is will be the Arrhenius concept in the acid reaction. So it is does not explain the behavior of acid and base in non-aqueous solvent. It is does not. So you underline the word page number 3, the limitation of Arrhenius concept. So does not explain the behavior of acid and base in non-aqueous solvent. The example is acetone and tetrahydrofuran. Okay, children. The next, the example of base. So in the base, ammonia NH3 is base. Okay. So in the aluminium chloride is acid. There is no hydrogen ion. Then ammonia is base, is no hydroxyl group ion, OH minus ion. Okay. So it does not contain hydroxyl ion. So ammonia is not give hydroxyl ion group. So it does not count for the basicity of the substance. Okay. So there is two limitation of Arrhenius concept. So in this Arrhenius theory or Arrhenius concept is based on acid and base. So acid and base in the presence of aqueous medium, then 2 points of limitation. Okay children, then the evaluate yourself example. So in the first example, HNO3, what is the name of formula HNO3? Nitric acid. Okay, HNO3. So in the presence of aqueous medium to formation of H plus NO3 aqueous medium. Okay, all the reaction is aqueous medium in Arrhenius concept. Okay, then the second reaction, then the second example is barium hydroxide, BaOH2. Okay, so in this presence of water, then so it is separated to form of barium 2 plus 2 OH minus. Okay, this is the basis form. So in the nitric acid to form, as it is formed, then barium hydroxide is formed base. Okay, base in the aqueous medium. Then next boric acid, H3 PO4, boric acid to form the presence of water to form 3H plus PO4, the aqueous medium. The aqueous medium. So in the formation of acid is formed. The formation of acid. Then the next one, acetic acid. So acetic acid formula CH3COOH. In the presence of water to form H plus H CH3COO minus. CH3COO minus is the as it is formed. Okay. So in the nitric acid to form acid, barium hydroxide to form hydroxyl ion, boric acid to form acid H plus, then acetic acid to form acid. Okay, this is the evaluate of yourself, page number 3. Okay, then the next topic is Lowry-Bronstein. Okay, Lowry-Bronstein theory. It is a proton theory. So in this theory is the concept of acid and base is proton donor and proton acceptor. So in the Lowry-Bronstein theory is otherwise known as proton theory. Okay, so proton H plus simple. Okay, so in this acid, so acid is donate a proton to another substance. Okay, acid is donate a proton to another substance. Donate a proton to another substance. So it is called the proton donor. Okay, so acid is proton donor. Okay, so acid is proton donor. Then base. So base is accept a proton from, okay, accept a proton from other substance. Accept a proton from other substance. So it is called proton acceptor. It is called proton acceptor. So this is the small definition. So Lowry-Bronstein theory is otherwise known as proton theory. The proton is simple as H plus. So acid. So acid is donate a proton to another substance is called proton donor. Base is accept a proton from other substance is proton acceptor. Okay. So next example reaction. So in this reaction, hydrochloric acid is react with water. Okay, so hydrochloric acid simple HCl. Okay, so HCl, hydrochloric acid, is react with water. The reversible reaction of hydronium ion H3O plus Cl minus is formed. So in this reverse reaction, so in this reverse reaction, so in the H plus and Cl minus ion. So in the H plus ion, in the H plus ion is moved to water. In the H plus ion is moved to water. So this is called acid 1. Okay, acid 1. This is base. Okay, this is base 2. Okay. Then next this is acid 2, this is base 1. Okay, so in the acid 1, so acid means proton donor. Okay, acid means proton donor. Okay, acid means proton donor to the formation of, what is this reaction? Acid 2 reaction. Okay, acid 1 proton donor. So in the water molecule is the base is accept, the base is accept a proton. Okay, so accept a proton is base to form acid 2 hydronium ion. Okay, hydronium ion. Then next base. So in this base in the reaction to the formation of base 2 converted into base 1 is Cl1. Okay, Cl minus 1 chlorine atom is present. Okay, 1 chlorine atom is present. So in the acid is proton donor. Okay, acid is proton donor. Base is proton acceptor. Okay, base is proton acceptor. Okay, then next another one reaction, the water is react with ammonia. Okay, water is react with ammonia to form ammonium salt is formed. Okay, ammonium salt formula NH4. So water is react with ammonia to form NH4 plus OH minus. So in the H2O to separate H plus OH minus. Okay, so in the H plus ion is moved to ammonia. Okay, this is acid and base. Okay, ammonia is a base. Okay, so acid is a proton donor, base is proton acceptor. So the formation of ammonium salt, NH4 plus ammonium salt is acid and OH minus is base. Okay, so two general reaction, the acid and base reaction. Then next, the conjugated acid and base pair. The conjugate acid and base pair. So you see the first reaction, hydrochloric acid is react with water to formation of hydronium ion. So this is the conjugate acid and base pair. Okay. So in this acid and base pair you write the reaction. So all of you write the reaction, hydrochloric acid is react with water to form H3O plus Cl minus. Okay. So in the HCl to Cl, okay, HCl to Cl, this is one conjugate acid and base. The next H2O to H3O plus, this is another conjugate acid and base. Okay, conjugated acid and base. So next you see in your book page number 4 in the evaluate yourself. So in this evaluate yourself, in the first one ammonium salt NH4 plus. So in the conjugate acid and base you write the conjugated reaction. So in the first reaction ammonia NH4 plus. So in this ammonium salt is react with water to form NH3 ammonium plus hydronium ion. Okay, hydronium ion. Okay. So which is acid and which is base? So in the ammonium salt is acid 1. Then H2O water is base 2. Okay, base 2. Then next NH3 ammonia is base 1, then hydronium ion is acid 2. Okay, so you write the conjugated value. So in the conjugated value is NH4 plus 2 ammonia. This is one conjugate acid base pair. Okay, acid base pair. The next conjugate acid and base pair is H2O to H3O plus. So this is another conjugate acid base pair. Okay, children. So this is ammonia salt example. Okay, so you write the conjugate acid and base. The next is sulfuric acid. So in the sulfuric acid, you write the sulfuric acid formula H2SO4. Okay, H2SO4. So you write, so all the reaction present in aqueous medium in water. Okay, so H2SO4 plus water. Okay, plus water in the presence of aqueous medium to form HSO4 minus plus H3O plus. Okay, so which one is acid? So acid is a proton. Acid is a proton donor and base is proton acceptor. Okay, you see in your note, acid is proton donor and base is proton acceptor. Okay, so in this reaction, sulfuric acid is acid 1, then water is base 2. So in the formation of HSO4 minus is HSO4 minus is base 1 and hydronium ion is acid 2. Okay, so in this reaction, the conjugate acid and base pair is acid. Acid 1 to acid 2 is one conjugate acid and base pair. Then base to acid. Okay, base 2 to acid 2. Okay, base 2 to acid 2 is conjugate acid and base pair. Okay, so this is one mistake. So acid 1 to base 1. Okay, acid 1 to base 1. Okay, so this is conjugate acid base pair. So sulfuric acid 2, so HSO4 minus. So this is acid 1 to base 1. So this is conjugate acid base pair. Then base 2 to acid 2 is conjugate acid and base pair. Okay. So in the third example, is acetic acid. So acetic acid has CH3COOH. So in the CH3COOH is react with water. Okay, is react with water to form CH3COO minus plus H3O plus. Okay, so water is a base. So acetic acid 1. This is base 2. Okay, then this is base 1. Okay, base 1. This is acid 2. Okay, so you write the conjugate pair. So in the conjugate pair is acid 1 to base 1, then base 2 to acid 2. This is the conjugate. Okay, conjugate acid base pair. Okay, conjugate acid base pair. Okay, the next example, your book back question. Okay, book back question number 3. Okay, book back question number 3. So this is your book back question number 3. Identify the conjugate acid and base pair for the following reaction. So in this aqueous medium. Okay, So in the first reaction, hydrogen sulfide is react with hydrogen fluoride to form fluorine gas, and fluorine is aqueous medium plus hydrogen H2S, hydrogen sulfide, okay, H2S, aqueous medium. So in this reaction, you write the conjugate acid and base. So hydrogen sulfide. So hydrogen sulfide is base. Okay, hydrogen sulfide is base. Then hydrogen fluoride is acid. Okay, hydrogen fluoride is acid. Then so in this acid is hydrogen proton donor. Okay, acid is proton donor. Then base is proton acceptor. Okay, base is proton acceptor. Okay, so in this acid is converted into base. Base is converted into acid. Okay, so in this acid 1 is converted into, okay, acid 1 is converted into base 1. Okay, acid 1 is converted into base 1. So this is one conjugate acid and base reaction. Okay, so in this conjugate pair, you write the conjugate pair. So in the conjugate pair, okay, conjugate pair, so in the first one HS, okay, HS minus and H2 yes, then second acid 1 to base 1 is HF and F minus. Okay, so in the acid 1 to base 1 is one conjugate acid and base pair. Then second one is base 2. Okay, base 2. So this is base 1. The proton donor, the proton acceptor is base. So this is base 1, this is base 2, this is acid 2. Okay, this is another conjugate pair. Okay, so in the next question, so what is the next question? You write the question in your note. HPO4 2 minus. Okay, HPO4 2 minus. In this reaction, I write the reaction HPO4 2 minus plus SO3 2 minus to give the reaction PO4 3 minus plus HSO3 minus. Okay, so which is acid, which is base. So base is SO3 2 minus is a base. Okay, SO3 2 minus is a base. So this is acid. So this is acid 1. This is base 2. Okay, acid 1. This is base 2. So acid is converted into base. Okay, so in this proton, okay, in the proton, acid is a proton donor. So in this proton donor to form of base. Okay, so in the acid 1 to form base 1. Okay, acid 1 to form base 1. Base 1. So this is one conjugate pair. Okay, you write the conjugate pair. So in the conjugate pair, so in the first one, HPO4 2 minus 2PO4 3 minus. The next conjugate pair is base 2 to acid 2. Okay, this is base 2 to acid 2 is next conjugate pair. So you write the formula SO3 2 minus HSO3 minus. Okay, this is the conjugate pair. Okay, so acid is a proton donor and base is proton acceptor. Okay, so you see, you write the acid and base, and next you write the conjugate pair. Okay, then the third example. So in the third example, ammonium salt. So this is the third example. The ammonium salt is reacted with the CO3 2 minus to formation of ammonia plus bicarbonate. Okay, so ammonia is a base. Already you know ammonia is a base. Okay, so in this proton donor is a acid. So in the ammonium salt is acid. Ammonia is base. Okay, right. Okay. So in this acid 1, so in one hydrogen one hydrogen is moved to base. Okay, so this is base 2, this is base 1. Okay, this is acid 2. Okay, so you write the conjugate pair. So in the conjugate pair is acid 1 to base 1. The next conjugate pair base 2 to acid 2. Okay, base 2 to acid 2 is the conjugate pair. So you write the conjugate pair. The conjugate pair, the first one is NH4 plus NH3. The next conjugate pair acid and base bicarbonate to CO3 2 minus. Okay, so this is your book back question example. You write the conjugate acid and base pair. Okay, so next in the limitation. So in the limitation of Lowry-Bronstein constant reaction, BF3 and boron trifluoride. Okay, boron trifluoride is BF3. Boron trifluoride and aluminium chloride, aluminium trichloride. Okay, boron trifluoride and aluminium trichloride is the limitation. In the limitation, boron trifluoride and aluminium trichloride, it does not donate proton. It does not donate proton. It does not donate proton. It does not donate proton, but it behave as acid. Okay, but it behave as this 2 is acid. Okay, so this is one limitation of Lowry-Bronstein theory. So in the substance like boron trifluoride and aluminium trichloride etc., they do not donate proton. Okay, so do not donate the proton. So it behaves as a acid. Okay, this is acid character of boron trifluoride and aluminium trichloride, but it is do not proton donor. Okay, proton donor. So this is the Lowry-Bronstein theory. Okay, so in the next concept is Lewis concept. So in the Lewis concept I teach next video. Then write your homework. So all of you write, this is your homework. Page number 30, your book back question number. Your book back question number is 1, 2, 3, 4. So first 4 questions you study and write your homework note. Okay children. So today we are learn about what is the topic. So in the acid and base. Okay, so what is acid and what is base? So acid is a sour taste and base is bitter taste, and then the concept of acid and base is Arrhenius concept and Lowry-Bronstein constant. Okay, so in this Arrhenius constant is the acid and base is defined in aqueous medium. Okay, some examples you saw. Okay, so all of you write all the equations in your note. Okay, and study. Okay children, so write your homework. Okay, write your homework. So book back question is first to 4 question you study and write in your homework note. Okay children, thank you.